Today we'll be starting with a new topic, about the electronic, topic 14. At the background, you do the nuclear question. Maybe tomorrow, maybe the last half an hour, we'll be discussing some questions about nuclear. Okay, tomorrow Saturday, we'll be having like the extra class at 1 o'clock. Okay. So, yeah. Okay, let me open up. Okay. Class can see the PowerPoint, right?
Yes.
Yes. Okay, good. So, if any problem arises, voice or something, please inform me earlier. Okay. Okay, so this is topic 14. This is going to be about electronic. It's electronic. It's about amplifier. You learn about transistor. Do anyone learn about transistor before? Like kind of like this, the symbol. You have NPN. So NPN or PNP, two type of transistor. O levels, do you learn about transistor? SPM, I think you do learn about transistor, right? Anyone? Okay. So what is transistor? Transistor is a device just amplify the signal. It's called transistor. Okay, we're going to talk about a big version of this transistor. That's called direct sensing and something called operational amplifier. Okay. First, in electronic, we're going to talk about all the sensing devices first. Okay, sensing devices first. Okay. First, yes. For direct sensing, electronic can be divided into 3 departments. The first department is sensing device. Okay, sensing the environment. Could be pressure, could be could be pressure, could be temperature, and so on. Sensing device, and that set like thermistor. The thermistor LDR will be used to sense it. Then the sensing device, the output will be sent to a processing unit. Processing unit is the brain. It's the brain of the electronic circuit. Normally, the processing unit is we call the op-amp, operational amplifier. It's the brain, which last time was the transistor. Now we call it, big version is operational amplifier. Then the processing unit will decide to on or off the output device. Okay. So now today's lesson is about sensing device, and we slowly go into the operational amplifier. Okay, the sensing device has a physical property changes with change in whatever it's monitoring. Okay, like LDR monitor the change resistance when light intensity varies. Okay, output device could be light, could be speaker, alarm, and so on. Loud output can be LED light. Okay, is the output device. Okay, so remember these 3 departments. First is sensing device, next is processing unit, third is output device. Okay. So sensing device, the one in your syllabus, which sense the the environment, actually is LDR. LDR, thermistor, something new, piezoelectric transducer, and the fourth one is strain gauge. Okay, LDR we know it measures intensity of light. Intensity of light. When intensity of light rises, what happened to the resistance? Resistance of the LDR decreases, and the voltage across LDR will decrease. So this the sensor, it senses light intensity. Okay. Thermistor sense what? thermistor sense temperature, and the temperature is rise, resistance of the thermistor drops, so voltage drops. Voltage drops. Okay, these are the two. Okay, piezoelectric transducer is a device sensing pressure. Okay, it senses pressure and change the resistance so that the voltage altered. So piezoelectric transducer sense pressure, and the strain gauge sense strain. What is strain? The extension over the original length. Strain. How big is the wire extended? The strain gauge. Strain gauge. Normally, strain gauge used to check cracks in the bridge. Maybe. Okay, you have a bridge. Let's say a bridge pillar. Okay, there is a crack occurs. They fix the strain gauge. They leave it for 1 day or maybe 1 month. They come and check the crack growth. How much the crack has grown. The crack going to be very small, maybe a few millimeters, less than a millimeter. So, but the sensing strain gauge can measure the how much it grows by connecting to an operational amplifier. Digital reading will come out. So, strain gauge sensing strain, piezoelectric transistor sensing pressure, and the other two, LDR and thermistor, you know earlier, intensity and temperature respectively. Okay, the first thing, light dependent resistor. This is the symbol, remember. And by sandwiching a film of cadmium sulfide between the two metal electrodes, its resistance can go from 1 mega ohm to 100 ohm. Okay, 1 mega ohm to 100 ohm. So when the light intensity is high, the resistance will be small. So 100 ohm expected when the intensity of light is very high. Yes, as we know, the resistance of LDR is constant at a constant light intensity. The LDR is sensitive to change in light intensity. Note that the change in resistance or the change in light intensity is not linear. Of course, not linear. When intensity rises, this is what important you have to remember. Light intensity rises, resistance drops. So voltage across the LDR. The voltage, you put a voltmeter across it, the voltmeter reading will drop. Okay, less voltage. Okay, next, thermistor. Thermistor is a device that change temperature. Thermistor device that is manufactured in various shape and size using oxide difference metal. So that there is a significant change in resistor for the temperature. So remember the symbol. Okay, this is a symbol for thermistor. Okay. Yeah. So the type of thermistor we're going to use is the negative temperature. You don't need to know in depth about that. But what you need to know is the other one. When the temperature rises, the resistance drops. When the temperature rises, resistance drops. Okay. Okay, so that's the two. Okay, the third one, piezoelectric crystals such as quartz have a complex ionic structure. Piezoelectric transducer we will be discussing in depth when we do ultrasound later. For time being, what you need to know is piezoelectric transducer is made of a crystal, unstretched center charge. This part, right? This entire part, I'm doing in depth in ultrasound. Okay, in ultrasound. The next topic. The next topic. For time being, what you need to understand about piezoelectric transducer is sense what you call pressure. Okay, it sense pressure. Okay, so electrical connection can be made to crystal opposite side of the crystal coated with the magnitude of the voltage generated depends on the magnitude of pressure. Okay, applied to the crystal. So piezoelectric transducer, you give greater pressure, the voltage will be higher across the piezoelectric transistor. Okay, so that's what you need to know about piezoelectric transistor. Is sensing pressure. Okay, greater the pressure, greater the voltage across the piezoelectric transducer will be. Increase, decrease in applied pressure. Yeah. The internal parts we will be discussing in the ultrasound later. For time being, you remember pressure sensed by the piezoelectric transducer. Okay, next, a sound wave consists of a series of compression reflections. If the wave is incident on a piezoelectric crystal, a varying voltage across the crystal will be produced. This voltage can be amplified. The crystal and amplifier act as a simple microphone. Yes, the piezoelectric transducer is actually exactly same as microphone. Your microphone. Microphone also sensing pressure. When you give sound, what happened? The electromagnet, the diaphragm is going to vibrate. There is electromagnet side. It produces a voltage. Okay, the pressure create a voltage due to Faraday's law. You know, the EM induction. EM induction happens like microphone. But in piezoelectric transducer, not using EM induction, it uses electric field. It uses electric field. The crystal inside will compress and expand to produce a voltage. Produce voltage. When you sense the pressure, when you sense when the crystal is compressed, the charges will be arranged such that it create a voltage. So piezoelectric transducer and microphone, both are sensing pressure. Both are sensing pressure, but their mechanism different. Microphone works EM induction method. EM induction method to produce voltage, and piezoelectric transducer uses crystal electric field to create voltage. The piezoelectric transducer is very sensitive compared to microphone. Microphone sends a very loud sound which made by human. We can listen 20,000 hertz and 20,000 hertz. Piezoelectric transducer can sense frequency greater than that, more than 20,000. Okay, that's why piezoelectric transducer is a part of ultrasound machine. Okay, to sense sound, okay, pressure. So for time being, remember, piezoelectric transducer sense what? Pressure. Pressure. Any questions so far? Okay, so let's move on. We're just talking about sense. Okay, next, the fourth one is called strain gauge. Strain gauge is made of sealing a length. 1 year came out. What is meant by strain gauge? You have to describe this. Strain gauge is made of stealing a length of very fine wire in a small rectangle of thin plastic. It's made of a very fine wire which can extend. Okay, when you extend the wire, the resistance is going to change, so the voltage is going to change. Okay. So strain gauge, when the plastic is stretched, the wire will be stretched. This causes the wire length to increase, and the cross-sectional area decrease slightly. Both these changes causes the resistance of the wire increase. Strain gauges are usually glued very securely in the material that under test. So when the fine wire which is this size, get longer, and they get longer because of the strain. Okay. As I said, used for the cracks one. Let's say you have cracks, you put the wire here, the strain here, and connected to op-amp, Okay, so the fine wire here will extend when the cracks. This is the cracks, when the cracks grows. When the cracks grows, this wire will extend. When the wire extend, what happened? The wire get thinner. The wire will get thinner. I think the area will get what? The area will get smaller, and the length will get longer. The L get longer. So what happened? The resistance will get greater. Resistance increases. So strain sense the strain gauge sense the strain. Therefore, the resistance of the wire change. Therefore, voltage will vary. And it senses what it sends to the op-amp. Okay, so that is strain gauge. Okay, so yeah, so this is the extra resistance law. When the length increase changes of L, this formula like area they assume like constant. So there will be a changes in R. Okay, changes in R. So changes in R found to be rho changes of L over A. So changes of resistance is directly proportional to the changes of length of the wire. Okay, so that's why this is the conclusion made. Greater the length of the strain gauge, greater the resistance going to be measured. Yeah. Okay, how the sensor is going to be fixed to the operational amplifier? The sensing device will register a voltage. The sensing device will be connected like this as a potential divider technique. Whatever sensing device we placed here at the bottom here could be, as I said, there are 4 types: LDR, thermistor, strain gauge, or what? The fourth one, piezoelectric transducer, will be fixed at the bottom. Another one resistor fixed at the top with a power supply. So what happened? When the sensor changes, when the sensor sense a different resistance, different quantity they measured change, its resistance going to change. Therefore, the voltage across them going to change according to the DC circuit board. And the resistance, for example, LDR, when the light intensity rises, the resistance will decrease. So the light intensity resistance will decrease. Therefore, voltage across LDR, let's say this assume as an LDR, the voltage across LDR will decreases. When the LDR decreases, you get a voltage reading, smaller voltage reading. So this smaller voltage reading will be registered inside the operational amplifier. And the operational amplifier will decide whether want to on or off the alarm or whatever. Okay, so LDR maybe can be used to switch on or off street light, maybe for street light, the road light, right? At 7 o'clock it on in the morning. In the evening 7 o'clock it is shut down, because the street light is connected with the LDR as a sensor and connected in a potential divider method with the operational amplifier in the board over there. Yeah, so LDR. Okay, thermistor, here this diagram got thermistor. Thermistor, when the temperature rises, what happened? The resistance will drop. So voltage across the thermistor will drop. So the voltmeter register low voltage reading. And again, you go to the op-amp, and op-amp will decide to switch on alarm or not, because thermistor sensing temperature. If temperature rises, op-amp will register a low voltage value. Op-amp will be connected the alarm. Okay, somewhere there is a circuit to show. So how the sensors giving input to the operational amplifier? It was connected in a potential divider method. Okay, in a potential divider method. Okay, so that's all our sensors. Okay, 4 sensors available. So we done the first department. And the first department is what? Sensing device. Second department is the operational unit. The third is the output. So we're done with the sensing. 4 types of sensing are there: LDR, thermistor, what is that? Piezoelectric transducer. Then fourth one is strain gauge. Strain gauge. LDR sensing light intensity, thermistor sensing temperature, piezoelectric sensing pressure, and strain gauge sensing strain. Strain. How big is the strain? Okay. Okay. Now this sensor connected to the brain, the operational amplifier. We call it operational amplifier. Okay. This is what the main part of the topic. The main part of the topic is about operational amplifier. Okay. You can see in this diagram, this picture is actually, operational amplifier is actually a IC. It's a integrated circuit. Okay. So operational amplifier, op-amp, in short we call it, it's a basic building blocks of analog electronic circuits. It's electronic circuits. A device that all properties requires nearly a DC amplification. It is an integrated circuit. It's IC. Okay. Your phone got a lot of chips, right? The small electronic chips is called IC, integrated circuit. Okay. So the size of one operational amplifier could be like, can say, like size of a 5-cent coin. Okay, your 5-cent coin may be this size. Okay, that's the size of the op-amp. It's very small. Okay, very small. Yeah. But inside this board, right, it consists of this much of kind of complex circuit in it. Okay, this is the internal circuit of the operational amplifier. Okay, In this circuit, you can see there are 20 over transistors are filled in. Okay, 20 over transistors are inside the board. Okay, so yeah, and connected with the resistor. Okay, so its function is what? Whatever what you call signal input into the op-amp, the operation amplifier will amplify the signal. A small signal millivolt, it amplified to a very high voltage. Okay, that's the function of the operation amplifier. Okay, now although this circuit looks complex, but we put a simple one symbol for operation amplifier. This is the symbol will be used. This is symbol for op-amp. It's like a triangle with a two input. One is positive, another one is negative. This is called positive input, non-inverting input, special name. And these two arrows is called power supply. This two is the power supply, okay, and this is one output. This is the lead X. Maybe two legs is like the V positive, V negative. Maybe another two leg, maybe for the power supply, connected to the supply, power supply, and maybe one of them will be the V out. Okay, like one leg will be V out. So this is the symbol, the symbol of an operational amplifier. You see, inside the operational amplifier like that, maybe two legs is the input, one leg is the output, power, two is power, and one is the output. Maybe leg 6 is the output, and so on. Okay. Any questions so far? So this is the brain of electronic circuit, operational amplifier, who get the input from the sensor and decide whether to on a output or not. Okay. Okay, guys. This is the 5 properties about operational amplifier, ideal operational amplifier. You must remember. Okay, the operational amplifier has 5 properties. Okay, in exam they might ask list out 3 properties of operational amplifier sometimes. Okay, so the first property of operational amplifier is the operational amplifier has a infinite input impedance. Okay, what is meant by impedance? Okay, impedance means it's like resistance, like resistance. Resistance of a wire. What is resistance means? A factor that opposes the current flow in the circuit. For a resistor, it's resistance. But if the circuit has resistance, as capacitor, as something called a coil, called inductor. Inductor not in your syllabus, but I tell you, if the electronic circuit consists of resistor, capacitor, and inductor, then capacitor also opposes current sometimes. Sometimes it opposes the current. If it charge opposite direction, capacitor also opposes the current from flowing one. We learned about that. And the inductor also will oppose the current when it becomes electromagnet. Okay, so resistance is the property of resistor oppose current. Okay, if it is made of capacitor and inductor, then we take another common term opposing current. It's called impedance. Okay, impedance means, so if they say the term impedance means the circuit not only contains resistor, it contains capacitor and inductor also inside. That's why we call impedance. Okay, so in your mind you just put impedance means a property that opposes current flow in the circuit, which consists of capacitor, inductor, and resistor. Okay, so take impedance as like a factor opposing current flow, like resistance. So for ideal operation amplifier, the input impedance is infinite. Input impedance is infinite. Means what? I go back here. That means when the voltage is going in, here the input impedance is very big. That means apparently what they are trying to tell, the current flow into the operational amplifier is zero. No current is flowing into the operational amplifier for an ideal operational amplifier because impedance is infinite. That's the first character of the ideal operation amplifier. It's an infinite input impedance. Okay, second, it has infinite open loop gain, voltage gain. Infinite open loop gain. Okay, what is the meaning by gain? Gain means the gain means output over input is called gain. Output over input. Let's say you have an operational amplifier. Okay, input you give 1 volt, output become, let's say, 5 volt. The gain say to be how much? Output over input is your gain. So 5 over 1 is your gain. So gain is 5. Okay. So 1 volt, you get output 5 volt. If 1 volt become 10 volt, we say gain become 10. For operational amplifier, for ideal operational amplifier, the gain is found to be infinite. Means what? You input 1 volt, the output say to be infinite volt. Big gain. That's open loop voltage gain. The main function of the operational amplifier is to amplify the input, as I told you earlier. And the more the open loop gain is, as the better. So for an ideal amplifier, the gain will be infinite. Okay, it's infinite. Okay. Next, zero output impedance. Okay. So for operational amplifier, the input is infinite. The input is infinite. The output impedance is zero. No output impedance. That means the current flow will be very big at the output. Output, the impedance is zero. Zero impedance. Input is infinite impedance. What is meant by impedance? A factor that opposes the current from flowing. So that is impedance. So output impedance is zero. The output impedance of the ideal operation amplifier is assumed to be zero, so that the whole output voltage is provided across the output load. Okay. So that is about 3 factors lah. Infinite input impedance, zero output impedance, infinite gain for an ideal operation amplifier. Okay. And the fourth one is bandwidth. Okay. The operational amplifier has an infinite bandwidth. It has an infinite bandwidth. What is meant by infinite bandwidth? You see, operation amplifier, if you give a signal at a particular frequency, let's say maybe 50,000 hertz, okay, it will amplify the signal, get bigger, amplify the signal, get bigger. But this op-amp, it should have a certain bandwidth. Bandwidth means if you give more than 50,000 hertz, let's say its bandwidth is up to 50,000. If you give more than 50,000, what happens? The amplification won't done properly. The amplification may be smaller. So the operation amplifier never works properly after it passes the range. So the open amp as an infinite bandwidth means what? If you give any input frequency, whatever frequency you give input, it's going to amplify it properly with the proper amplification. So the ideal operational amplifier is an infinite frequency response. Means what? Any frequency input, it gives the output with a correct gain. Okay. Yeah. So that's called infinite bandwidth. Okay. So like microphone. If a microphone, let's say on a stage, you are an opera singer, let's say is singing a song. Okay. The microphone was connected to an operational amplifier. Okay, the operational amplifier. Okay, let's say the opera singer produces a sound from let's say up to, let's say the op-amp has a bandwidth of, let's say 15,000 hertz let's say there's a bandwidth of 15,000 hertz. Let's say for instance the practical op-amp got 15,000 hertz of bandwidth. Let me see, more than 50,000 hertz it out of the bandwidth. Let's say the opera singer when sing a sound, maybe the gain of this op-amp may be quite big, say infinite. So when she sing a song, let's say, slowly, it's going to be very loud. Maybe let's say the gain, let's say, for example, I give a gain value, not infinite. Maybe let's say I give a gain value of 50. So what do you predict? When she says hello, the loudness of the hello going to increase by 50 times. If the pitch of the sound is less than 15,000 hertz. If the opera singer said hello with a different pitch higher than 15,000 hertz, let's say, what happened? The op amp out of the bandwidth, so the gain you're going to give won't be 50. You might give maybe 30. So the operational amplifier works less effectively when it's out of bandwidth. Okay, so that's mean by bandwidth. What is meant by bandwidth? It's a range of frequency where the operation amplifier works at its optimum level. That is bandwidth. But ideal operation amplifier has an infinite bandwidth. Infinite bandwidth means what? Any frequency you can multiply the voltage at the correct gain. Correct gain. So that's called infinite bandwidth. Okay. Next, the fifth one is called infinite slew rate. Okay, infinite slew rate. What is infinite slew rate? Slew rate is measure of time delay. It's a measure of time delay between the changes to the input and output. The time delay is called slew rate. Okay, infinite slew rate means this is weird. Infinite slew rate means time delay is 0. No time delay. With an infinite slew rate, the time, there is no delay. There is no delay. It's called slew rate. Okay. So operational amplifier, when an opera singer, let's say, sing a song, let's say, the operational amplifier will take time to process it, maybe few milliseconds, maybe. Greater the time delay for processing, the slew rate become smaller. Okay, but the ideal operational amplifier has an infinite slew rate. Means what? Instantly, whatever input given, the output will happen instantly, no time delay. It's called infinite slew rate. Okay, so these are the 5 character of operational amplifier. Okay, 5 properties of ideal operational amplifier. Ideal means perfect one, which we don't have one. Like ideal transformer. Ideal transformer is a perfect transformer which has an efficiency of 100%. But in reality, practically, we don't have ideal transformer. Okay, same thing. Ideal op amp, these are the 5 features they have. So you must remember at least 3. So infinite input impedance. Out of these 4 are infinite. 4 are infinite. Remember the infinite is easier. It has infinite input impedance. It has a 0 output impedance. It has an infinite gain. It has an infinite bandwidth. It has an infinite slew rate. Okay, class. I know this is all something new for you. This is totally new it's about electronic. So you try to understand this one. This 5. Any questions so far? Okay. So although it's ideal operational amplifier, you have the real operational amplifier has actually some values. We say the input impedance is infinite, but in reality, the input impedance is around 10 to the power of 6 to 10 to the power of 12. Okay. So actually everything got value. But the one value you have to remember for the real gain is the gain value. The gain value for ideal op amp is how much? Is infinite, but the gain value for real op amp is around 10 to the power of 5. About 10 to the power of 5 means what? If you give 1 volt, I told you the output will be infinite volt for ideal operation amplifier, but for real operational amplifier, 1 volt, the output will be actually around 100,000 volt. 10 to the power of 5 is the gain experienced by a real operation amplifier. Okay. So other than that, you no need to remember. You have to remember the real open loop gain. It's around 10 to the power of 5. Okay. So any questions so far? Okay, no questions, Okay, so I just recap. Okay. So we learn about op-amp. What is op-amp? Is a operational amplifier integrated circuit. Inside got 20 over transistors. This is the symbol. Got 2 input. Got power supply. Got output. This is what physically looks like, and it has 5 characteristics. Okay, 4 infinite, 1 0. You have to remember. Okay. So real, the gain is 10 to the power 5. Okay. So now, as we read from here, so operational amplifier will have 2 input. The negative input called inverting input. Okay, inverting input. We call it inverting lah. The positive will call non-inverting input. Okay. The operational amplifier works based on this formula. This is the formula for operational amplifier. Okay. So you see carefully this formula. Okay. This is the output V out. A naught is 10 to the power of 5. A plus is the input in the positive terminal. A negative the input here. Okay. So from this formula, you should understand one thing. If V plus greater than V negative, output will be plus. If V negative greater than V positive, the output will be negative. Okay. The A naught is called open loop gain. Okay, the A naught is called open loop gain. Sorry. Okay. Yeah. So the circuit now developing slowly. So this you have 2 input and the power supply. The power supply is connected at the side here. This is the power supply. You don't need to worry about this battery. This is the power supply. Up here will be maybe positive 10 volt. Down here may be negative 10 volt. Okay. The power supply determines what is the range of voltage can come out from here. If you give positive 10, negative 10, the output will be within this range only. Cannot go more than positive 10. Cannot go more than less than negative 10. The output. Okay. The common link between the two sets battery is 0 volt earth. It's normally earth means 0 volt and be 0 volt. Then they put a battery here to give some voltage to this input. Okay. The A naught is always, we take it as 10 to the power of 5 typically. Okay, next one example. You see this circuit. The V positive given is 1.4 volt. V negative is 1.3 volt. Okay. The gain is 10 to the power of 5. So the operation amplifier when receive, so that means positive is what? Positive is 1.4 volt, and this 1.3 volt is inserted into the operation amplifier. The operation amplifier will use this formula. V out equals to A naught V plus minus. So 1.4, 1.3 times 10 to the power 5. The output will be positive 10,000 volt. Why positive? Because V positive is greater than V negative. That's why output become positive. You see 1.4, 1.3, 1.4 greater. So positive 10,000 volt. So the output here will be positive 10,000 volt instructed by the operational amplifier. The operational amplifier is like a judge class. It's like a judge. It's analyze the input and he said he want to give output of 10,000 volt. He decided to give 10,000 volt of output. Okay, but the output, how much output we're going to come out, depend to the power supply. Okay, power supply. If the power supply you give positive 10 volt and negative 10 volt only, if the op-amp want to come out with 10,000 volt, the power supply can't afford to give 10,000 volt. It's only 10 volt. So what the output will be? The output will be only 10 volt. Please understand this. The operational amplifier can tell you any voltage to be given out, but the decider is the supply. The supply will decide how much to give out. Let's, for example, like bank. Inside bank only got 1 million of ringgit. Okay, the manager instruct the manager instruct to pay someone with 2 million ringgit. So the bank can't afford it. It's only have 1 million. So only 1 million will be given. Same thing like that. The power supply only got 10 volt, but the op-amp requiring wants to disseminate like 10,000 volt. So the output only the power supply range is 10 volt. And this, as I said, you see this the box here. This is not possible. You can't produce 10,000 volt by the power supply. The output voltage cannot exceed the power supply voltage. Yeah. The amplifier is said to be, this situation said, the amplifier is said to be saturated. So the output will be the maximum power supply voltage. If you give positive 10, it will be positive 10, final voltage. Okay. Okay, for example, see this. Here, V positive is 3.652. V positive 3.652, V negative is 3.654. I put these two into the operational amplifier formula, 3.652, 3.654. Finally, 3.654 is greater. The negative input is greater, so output will be negative 200. According to the op-amp formula, found to be negative 200 volt to be released here. Okay, but again, depend on the supply. The supply only got positive 10 volt and negative 10 volt, so it asking for negative 200 volt. The power supply will give the lowest. You only give negative 10 volt only. The output will be negative 10 volt only. Because this situation has saturation happens, saturated. Okay, the amplifier is saturated. V output equals to the supply voltage. In this case, the output voltage is negative. So if I give negative 10, it will going to be negative 10 volt. Okay, saturation happens. Any questions so far?
So the A0 is always 10,000.
A0 is always 10 to the power of 5. Okay, A0 always will be 10 to the power of 5. 100,000 A0, the gain. Okay. Yeah. Any questions? Can you understand? Can I? Okay, so the conclusion is, you need to understand the conclusion. If V plus is smaller than V negative, the output going to be negative. If negative big, output negative. If positive big, positive input big, output going to be positive. That's what the op-amp design. Op-amp follow this formula. Okay, always. Okay, now go to the next one. You see the next one. The V plus is 0.9, V negative 0.899. So we put these two inside the formula, 0.9, 0.899. In this case, positive was greater than negative. So output was found to be positive 10 volt. So output is positive 10 volt. The op-amp said deliver positive 10 volt. But we have to check the power supply. What is the power supply here used? Positive 15, negative 15 has been used. So this case is okay. The power supply has more than the one requested. So what the power supply will give out? Will give exactly what required. You say positive 10, he give out positive 10. You only give positive 10 volt. In this case, the amplifier is said to be not saturated. It's not saturated. So let's then the power supply value asked, you give exactly the voltage which required. Okay, if the voltage by the op-amp is greater, the supply can't afford to give that voltage. It gives the maximum voltage it can. Okay, and that situation called saturation happen. Okay, saturation happen. Okay, any question from this slide? So for the amplifier not to be saturated, the two input must be almost identical. That means another thing what they are trying to say is op-amp is easily can get saturated, very easy to become saturated. Okay, small differences will do. If you give a big differences, it easily will be saturated. Okay, that's the character of op-amp. Okay. Okay, now we want to know what is the small differences in V plus and V negative prevent it from saturation. Okay, it was calculated V plus or V minus is V out over A gain. Let's say V out is 9 volt over 10 to the power of 5. So the differences must be between them. V plus and V minus must be difference with this amount. Okay, if an open loop gain of operational amplifier is 10 to the power 5, the supply is 9 volt. What is the minimum difference in the input voltage will cause the output to be saturated? If the difference is less than this, it won't be saturated. But what do you conclude from this working? The op-amp is easy to saturate or difficult to saturate? It's easy to saturate. A small slight difference, it will saturate. Okay, the output will saturate to the power supply's voltage. Okay. Okay, any questions so far? So this is the today's lesson. Okay. So recap what you learned today. So you learn about which part? Okay, go to here. Okay, so you learn about the first department and half of the second department. First department, you learn about all the sensing device. How many type of sensing device are there? 4 in your syllabus. LDR, thermistor, pressure, what do you call piezoelectric transducer, and strain gauge. Okay, piezoelectric transducer we'll discuss in depth in ultrasound later. Okay, so LDR sensing what? Light intensity. LDR sensing light intensity, and thermistor sensing temperature, and piezoelectric transistor sensing pressure, more voltage, and strain gauge is sensing strain, more voltage, and they will be connected potential divider technique to the op-amp. Okay, then you learn about operational amplifier. What is operational amplifier made of? Made of 20 over transistors, and this is how the circuit symbol looks like: 2 input, 1 output, and it has a 5 special character. 4 infinite, 1 0. You must know at least 3. Okay, but the real one, the gain is only 10 to the power of 5. And we get to know that this is the formula used by the op-amp. Okay, and the op-amp can saturate. Okay, the output can saturate if the output greater than the power supply. Okay, that's what you learned today. Okay, any question class today? Okay, so I know that today is all our new stuff. You read about this. Okay, so tomorrow 1 o'clock will be continue from here. We'll be continue from here. We'll be discussing this circuit. Okay, so tomorrow's lesson is very important. Try to attend 1 to 2:30. Okay, most probably I'll finish maybe 2:15 or something like that. So make sure you attend. Any questions? Okay, class. So I stop here. So see you tomorrow, Saturday 1 o'clock.
Okay, thank you.
Thank you. Bye.